Here we want to compare these two numbers, and the numbers are quite large. And in our previous video, we discussed that when we have large numbers, one way easier solution to compare them is to find two numbers representing them, two small numbers representing them, and then compare those two small numbers. And one way to get there is to take logarithm of each number, because logarithm gives you a smaller number. Where it comes from? Well, we know if A is larger than B, then logarithm of A is larger than logarithm of B. Okay, if I take logarithm for this, then it is logarithm of 1000 to the power of 999, which is 999 times logarithm of 1000. Why is that? Because logarithm of A to the power of B equals B times logarithm of A. And if I take the logarithm of this number, it would be logarithm of 999 to the power of 1000, and this equals 1000 times logarithm of 999. Okay, so instead of comparing this and this, now I need to compare this and this, which are smaller numbers and are easier, but I think they are still not, the comparison is still not straightforward, and we can uh, further simplify it. So that's where we apply the second trick. And what does the second trick says? It says if A is a big enough number, like the orders of hundreds, then we can say that natural logarithm of A minus 1 can be approximated by natural logarithm of A minus 1 over A. And if we want to write the general form is that if A is large enough, then logarithm of A minus 1, the base of B, can be approximated by logarithm of A to the base of B minus 1 over A times natural logarithm of B. Okay, so if we take natural logarithm of the two large numbers, now we have this natural logarithm and this natural logarithm, and I think we can apply this trick here to somehow rewrite the logarithm here in the format of this logarithm. What does that mean? That means we can write 1000, or maybe we can skip that and write this. We can write logarithm of 999 as logarithm of 1000 minus 1, okay? And this is approximately equal to logarithm of 1000 minus 1 over 1000, all right? And if I replace this expression here, then I need to compare, instead of the two numbers here, I need to compare this and 1000 times this, okay? So I need to compare 999 times natural logarithm of 1000 with 1000 times natural logarithm of 1000 minus 1 over 1000. So these are all natural logarithm, okay? So I need to compare this and this. And if I distribute this 1000 to this expression in the parentheses, then I would get 1,000 times natural logarithm of 1,000 minus 1, because this is 1,000 times 1 over 1,000. So I need to compare this with 999 times natural logarithm of 1,000. Which one is larger? So I make an assumption. So I presume that this is larger, and now it's an inequality. We can double check. If I reduce 1,000 times natural logarithm of 1,000 from each side and add 1 to each side, then I would get, or sorry, if I uh, add 1 on each side, okay, and if I reduce 999 times natural logarithm of 1,000 from each side, then I would get 1 smaller than natural logarithm of 1,000. So you can try that. I skipped that part, that step. And well, we know that uh, logarithm of a to the base of b is larger than 1 if a is larger than b, okay? And we know that 1,000 is larger than, because this is logarithm of 1,000 to the base of e, okay? And we know that this is way bigger than e, so this means this is this logarithm of 1,000, natural logarithm of 1,000 is bigger than 1, and that means our assumption is correct. So this assumption is correct, all right? And what this is telling us, well, we were actually comparing uh, this number, and this number was representing this, and this number was representing this, and we somehow concluded that the number on the right, that means this number, is larger than the number on the left.